Hello guys, welcome once more to another video on linear transformations. So this question right in front of me says find the values of lambda and mu for which the transformation with matrix. Let me just give you guys a matrix. The matrix of transformation is actually 1 2 mu 2 lambda -2 and 3 6 -3. So that's the transformation matrix. So the question is saying we should find the values of lambda and mu for which the transformation with this matrix maps arrow cube onto a line, and then we should find the equation of the line. Okay, so arrow cube is actually space, okay, the whole space, and the dimension, in fact arrow cube is space. Now if we are mapping arrow cube onto a line, okay, you realize that there is a decrease in the dimension. Right, there's a decrease in the dimension because a line will have just some specific points on it, but space has all points. So you realize that mapping from arrow cube, which has all points, onto a line that has some specific points, then there is a decrease in the dimension. And for that to happen, then the determinant of the matrix involved has to give us 0, or in other words, the column vectors of the matrix are supposed to be parallel. So that's all you need to note. So we are going to use that fact to find the values of lambda and mu. Okay, so we use the fact that the determinant of the matrix has to be equal to 0. Then later I'm still going to use the other fact that the column vectors, because remember that when the determinant of a matrix is 0, it means that the column vectors of the matrix are parallel, or rows. Okay, so the determinant is equal to 0 means that the determinant of 1 2 mu 2 lambda -2 3 6 -3 is equal to 0. Okay, so what does this mean? Now let us find the determinant. If we cover 1, we are going to be left with lambda -2 6 -3. Then when we are going to 2, we need to attach the negative sign, so we get 2 -2 3 -3. Then when we are going to mu, we need to attach the positive sign, and we get 2 lambda 3 6. Yes, I think that's it, equal to 0. Now let us simplify. Here we are going to have -3 lambda minus -12. Then here we have -2 into -6 minus -6. Then plus mu into, we have 12 minus 3 lambda equal to 0. Okay, so let me just try to simplify. You realize that this man here is going to give us 0, right? It's going to give us 0. Now we are going to have the determinant equal to 0 to imply that now this component here, we are going to have -3 lambda plus 12. All right, now this component here, if we expand, we are going to have plus 12 mu, yes, plus 12 mu plus 12 mu minus 3 lambda mu equal to 0. So if I divide every term by 3, since 3 is a common factor, if we divide every term by 3, we are going to be left with negative lambda plus 4, then plus 4 mu minus lambda mu equal to 0. So look at the way I'm going to write the terms. I'm going to bring in the terms, that is, I'm going to write these two terms like this. I'm going to take negative lambda minus lambda mu, and then now plus, I'm now going to take 4 plus 4 mu equal to 0, so that I can factorize negative lambda and I get 1 plus mu, and then I factorize 4 and I get 1 plus mu, and I equate to 0. So let us move on to the next slide. So previously we have that the determinant is equal to 0 implies that we had negative lambda into 1 plus mu plus 4 into 1 plus mu is equal to 0. Now we can factorize 1 plus mu. When we do that, we are going to be left with negative lambda here plus 4 equal to 0, which means that 1 plus mu is equal to 0 minus lambda plus 4 is also equal to 0. So when we solve, we are going to get sorry, here we are going to get lambda, no, mu first. We are going to get mu to be equal to negative 1 and lambda will be equal to 4. Voila. So these are that's the value of lambda and that's the value of mu. Okay, so if we want to use the fact that the column vectors are supposed to be parallel, then we can also use it. But anyways, using it or not using it, we are still going to have the same answer at the end of the day. Okay, so let's just find now the image. Let's find out that equation of the plane. Sorry, let's find that line, which is the image of space under the transformation. So we are going to, let's just go to the next slide. So the transformation matrix, okay, I'm going to write the values of lambda and mu. We have had that lambda is equal to, we have had lambda to be 4 and mu to be minus 1. So the image of space is actually the image of all points in space, which is x, y, z. And to get the image, if I call the image of x to be x prime, the image of y to be y prime, and the image of z to be z prime, then this is just equal to, we need to take the matrix of transformation 1, 2. In the place of mu, we need to replace it with negative 1. Then 2, in the place of lambda, we replace it with 4. And then we have minus 2. And then 3, 6, minus 3. Voila. So we multiply it with a point x, y, z. Okay. So because x, y, z is in space, so we need to find the equation of that line. So what does this mean? It means that x prime is equal to, if we do the matrix multiplication, we get x plus 2y minus z. Now y prime will be equal to, we get 2x plus 4y minus 2z, and then we get z prime to be equal to 3x plus 6y minus 3z. Okay, so the objective is to actually get the equation of the line. So we need to eliminate x, y, and z. Okay, and we have an equation in terms of x prime, y prime, and z prime only. So we need to introduce the vectors here. So what am I going to do? If you look keenly, you realize that, let's just rewrite those equations. We are going to have x prime to be equal to x plus okay, now I'm going to write this man here, this term here, 2y minus z. Now look at what's going to happen. Y prime will be equal to 2x plus, now from the term 4y minus 2z, if we factorize 2 from there, we are going to get what? We are going to get 2y minus z as leftover. And finally, we have z prime is equal to 3x, right? 3x plus, from the term 6y minus 3z, we are going to factorize 2, so that we are going to be left with, no, we are going to factorize 3, so that we are going to be left with 2y minus z. Voila. Okay, now you realize that 2y minus z is like something which is common in all the equations, so we can let it to be the parameter. So if maybe I let 2y minus z to be equal to lambda, right? Then what do we have? We have that x prime will be equal to x plus lambda, y prime will be equal to 2x plus 2 lambda, and z prime will be equal to 3x plus 3 lambda. Okay, So it therefore means that my x prime, y prime, z prime will be equal to, now I'm going to factorize x. Okay, we are going to want to write it as vectors, so I'm going to factorize the number x. I have 1, 2, 3. If you look clearly, the coefficient of x here is 1, here is 2, and here is 3. Then plus, we now factorize lambda and we get 1, 2, 3. Is it making sense? Remember that the vector equation of a line is actually kind of in the form r equal to OA plus lambda d, kind of. Okay, so you realize that what do you realize from here? Anyways, I've realized something, so let us wipe it back, guys. You see that from the first equation, these three equations again are still related. Okay, these three equations are still related. Now look at what I'm going to do. Follow keenly. We are going to have x prime to be equal to x plus lambda. Now see what y prime will be equal to. 2 into what? X plus lambda, right? And then see what z prime will be equal to. 3 into what? X plus lambda. Voila. So again, we are going to let x plus lambda to be another parameter. So if we set x plus lambda to be equal to beta, that's still a parameter. Then what are we going to have? We are going to have x prime was actually equal to x plus lambda, y prime was equal to 2 into x plus lambda, and then z prime was equal to 3 into x plus lambda. So having beta to be equal to x plus lambda, it means that x prime will be equal to beta, y prime will be equal to 2 beta, and z prime will be equal to 3 beta. Okay, so from here, what do we see? From here, you just realize that if you want to get the vector equation, so vector equation, we are going to have x prime, y prime, z prime to be equal to beta into 1, 2, 3. So this is just the equation of a line that is passing through the origin. Okay, it's passing through the origin, and the direction vector is I plus 2j plus 3k. Now if you want to get the Cartesian equation, you realize that x prime will be beta. Now y prime divided by 2 will be beta, and z prime divided by 3 will be beta. Since beta is the same, we are going to have x prime to be equal to y prime over 2 equal to z prime over 3. So this is the Cartesian equation of the line. So the Cartesian equation. So this is a vector equation, this is a Cartesian equation, and then this is a parametric equation. So guys, thank you for watching, and see you in the next video.